Okay, this is Unit 7, Lesson 7. The warm-up vocabulary review: state the division property of equality. Who has the division property of equality? You guys remember? We use these to solve equations. This is one of the properties we use to solve equations. Does anybody remember what it is? Take a try. Give it a shot. Try. If you're going to do nothing and just be passive about yourself, come on, try. Somebody try. Give me an answer. Volunteer. Division property of equality. The property basically tells you what it is. Please put that away. Whatever it is you're crumpling up, put it away, please. Kimberly? Go ahead. What is it? Okay, you're thinking of division property of inequality? Okay. The inequalities, the rule is very similar, but for division property of equality, if you divide both sides of an equation by the same non-zero number, the results are equal. Now, there's a reason why they say non-zero, because you can't divide by 0. You guys remember that? Mm-hmm. That's a thing that's going to come up again and again and again in math. All the way up through calculus, you're going to see that. Division by 0 is undefined. Okay? So if you're using division property, you can divide by anything, but you just can't divide by 0. Okay, now, how do we solve this first equation? If you use mental method, that's fine, but I would prefer you guys use the division property of equality. Go ahead. Nice. So you use the division property of equality, and what did you do? What does that mean?
Well, you divide 3 by 1 side.
You're going to divide both sides by 3. Very good.
Oh yeah, I remember now.
Okay. And now we got to simplify that. What happens when we divide both sides by 3? What happens to the left-hand side of the equation? What's going to happen with these 3's? 3 divided by 3 is 1. What's 51 divided by 3? 17. So we get 1n equals 17. Okay, and then what's 1 times n? It's just going to be n. So we get n equals 17. Okay, moving along. Number 3. Who can walk us through number 3? I have x divided by 4 equals 12, or x fourths equal 12. How do I solve that? I feel like you've come a long way with solving equations. How do we solve this? What's the first thing I got to do? Denaya?
Make the whole number into a fraction.
You could do that, but I would say there's a property we're going to use. What's the property we're going to use? Well, what were you going to do next?
So I was going to cross multiply.
Okay, so you turn it into a proportion and then cross. Okay, we could do it that way. That's one way to do it. And you're going to get the same answer if you turn that into a proportion, make it 2 ratios. But it's actually a little easier than that. But I like that you brought that up because there's more than one way to solve this equation. Go ahead. I got x, and it's with divide by 4. How do I get rid of divide by 4? I do the opposite, which is what? I got to multiply both sides by 4. That's the multiplication property of equality. So over here, I'm going to multiply by 4. If it lets me multiply by 4. Oops, I know why. Okay, there, let me multiply by 4. But over here, I can't multiply this side by just a regular 4 because this is a fraction, x over 4. X fourths is a fraction. So I need to multiply by a fraction that's equivalent to 4. What's that going to be?
2.
I see some people making the gesture with their hands. Tell me what you're writing in air.
2.
No, 2 is not equal to 4. I need a fraction that's equal to 4.
1.
Well, what about 1? No, 1/4 is not equal to 4.
1.
Richard, help out. Right, 4 over 1 is equal to 4, right?
Oh.
And so what happens when I multiply these fractions on the left-hand side? What does that become? Remember how to multiply fractions? It's the easiest one. I told you guys early in the year. I said, this is the easiest operation to do with fractions. What do we do?
Oh, that, the 1 times x, it becomes 1x?
This does become 1x, so that is correct. It becomes 1x, but, and then 12 times 4 is 48. But I just wanted to kind of review with you how to multiply fractions. When I multiply two fractions, the numerators multiply, that gives 4x, and then 1 times 4 gives me 4 in the bottom. You guys see that? You guys remember that? Okay, and then we see 4 divided by 4 gives me 1. It still equals 48. And then 1 times x is just x. Okay? Little review for you. I know we haven't solved equations in a little bit, but hopefully it's coming back to you. All right. Any questions about the warm-up? Yes?
On the tester quiz, is both ways revealed?
Well, we're actually going to see another way that relates to yesterday. So it just depends on the question. Sometimes one method is easier than the other, depending on the situation. Does that make sense? Okay. Let's go ahead. All right, I'm going to go ahead and read this to you since I'm making the class video for it. What you'll learn, to use equations to solve problems involving percents. Why learn this? Suppose a ski resort reports that 60% of its trails are open. If you know how many trails are open, you can solve an equation to find the total number of trails in the park. You can translate percent problems into equations to find parts, wholes, or percents. So yesterday, remember when we used ratios and proportions? We set up a proportion, and we are either finding part, the whole, or the percent. Do you guys remember that yesterday? We set up a proportion, and we were trying to find one of those three, right? We're doing the same thing today, but we're not going to use ratios and proportions. Now, what you can do is you can set these up that way and solve it using this method and see that they're both equal. But let me walk you through this first example. Finding a hole, okay? So a ski resort in New Hampshire begins the season with 60% of its trails open. There are 27 trails open. How many trails does the ski resort have? Well, we know the percent that are open, right? There's 27 trails, and that's 60% of all the trails at a ski resort. Got it? What do we not know? What are we looking for? What are we trying to find? How many trails the ski resort has altogether, right? So that's my variable. I'm going to call our variable, I'm just going to say x. Let x equal the number of trails at the resort. Are we good? Okay, now I got to come up with an equation. Let me show you this equation now. And you're going to use this as a model to solve the next problem. So here's my equation. What do you notice about this equation? There's something that jumps out at you right off the bat. If you notice, I color-coded some things. I got the 27. Did 27 change? Okay, do you see where it is in the equation? My x. Do you see where my x is in the equation? I even matched the color again. 60%. Is 60% in the equation? It is, but it's not a percent, is it? Okay.
It's a decimal.
Who can tell the class, how do we go from a percent to a decimal? What do we do? Savannah?
You gotta move the decimal
2 times. And when we're trying to go from a percent to a decimal, we move it away from the decimal sign, or the percent sign, right? So we're going to move it 2 places to the left. Do you guys see that? And that's my decimal equivalent of that percent. Okay? Now, so here's my equation. You can say, if I got rid of this 0 behind the 6, I could say 6/10, or I can say 60/100 times x equals 27. Now, just like the warm-up, how do I solve that? How do I get my x by itself? What am I going to do? Who can help us out? You don't have to tell me what it is. Just tell me what I'm going to do, and I'll walk you through the calculations. Maya? I'm going to divide. What am I going to divide by? By 0 and 60/100. And we got to do that to both sides because that's what's with my variable x. So if I do that, what happens to 0 and 60/100? Think about the warm-up. It becomes 1x or just x. And then I'll just tell you right now, a little review. When we divide this, if you're on top of the fraction, where are you at? In the house or out of the house? If you're on top, you're in. If you're on the bottom, You're out of the house. So take a look at this. I'm going to take, and we're going to work this out. Now, does anybody remember how we do long division when the number outside the house has a decimal? Does anybody remember that? Sergio, what happens? I got annex zeros, but why am I going to annex zeros? You're right, I'm going to do that, but why? Can somebody help Sergio out? Leonardo? Not quite yet. We can't divide until we do something with annexing zeros. What is it that we got to do? Caden, can you help out?
Add another zero.
I do have to annex 0 or add zeros, that's true. But why am I going to add zeros?
Because you cannot,
Trinity, do you know? I got to put some, I got to do something with the decimals. Does anybody remember? Akvana? Well, Fatima, I'm going to give you one more try. I got to make the number outside the house a whole number. Okay? And so I can't have a decimal outside the house. So I have to move it 2 places. So if I move it 2 places, watch this. 1, 2. I also have to move this decimal that's right here. I got to move it over here. So it's right here now. Do you see where my decimal ends up? Are we good? You guys see where the decimal ends up over here? And then I got to bring it straight up. Now, this is a 60 now. It's no longer a 60 hundredths. It's a 60, a whole number. So, 60, does it go into 2? Does it go into 2? No. Will 60 go into 27? Will 60 go into 270? Yeah. Well, 60 twice is how much?
120.
120. We still got to keep going. What's 63 times?
180.
180. What about 64 times?
240.
240. If I do 65 times, what's that? That's 300, right? That's too much. So 60
times 4.
60 times 4 is what we want. So I'm going to go ahead and put up here 4. And then 4 times 60, like Caden says, 240. And we're going to subtract that. And 270 minus 240, what's that going to be?
30.
30, very good. Okay, and now I'm going to bring the 0 down. So I got a 0 here. So now I got to see how many times does 60 go into 300? 5 times. And what's 5 times 60? 300. It's okay. And we subtract that, and we have nothing left over. So guess what? I got 45. There, my decimals at the end. That is my answer. Okay. Now, what I want you guys to do is I want you to take a look at this problem, and I want you to model this problem right here. You're going to use the model to solve this problem.
Tori Best,
Go ahead.
Please come to the front office for early dismissal. Tori Best. Joelle Henney, please come to the front desk for early dismissal. Joelle
Try to work
Henney.
this out using the model as an example on how to set it up and solve it. Okay, I see like maybe half of you are looking at this and trying to write something down. The other half of you, not so much. Now, in about 20 seconds, I'm going to ask somebody to share with the class their formula. In 20 seconds, everybody should at least have their equation. So what I need you to come up with is an equation. Use the first example as a model for your equation. set up your equation. I'll read the question. A plane flies with 54% of its seats empty. If 81 seats are empty, what is the total number of seats on the plane? So we know the percentage. We know the part. We're trying to find the whole. So it's just like the last problem. Who can tell me the equation that they came up with? Akpana, go ahead.
54% number of empty seats is 89.
What's your equation? Do you see how we got the equation in the last example? So I need you to set up your equation so we can solve it. So here's what we got. Okay, we don't know how many total seats are there, right? What's my equation going to be? Can you help the class out with that?
0.54
Nice. So you have the right decimal. You made the decimal. And then what else?
times x
Hmm.
equals 89.
Nice. So she is absolutely correct. Here's the equation. Now, I need you to solve it just like we did up here for the previous example. And there's a handful of you that need to practice doing division with decimals. Okay, what did you guys get? Can somebody share with the class their answer? Sergio, go ahead.
150.
150. You guys, did everybody get 150? Okay, so I actually, it's not here on the smart board, but if you look, it's right over here. Do you see it? Do you see it? Check your work. Check your work. I'm going to copy my work from the dry erase board to the smart board. You should be adding your corrections in as well. Okay, this is where some people stopped this morning. I just wanted to raise this point. I had a number of students say 15. For some reason, they saw the 0 and they thought they were finished. No, you have to continue to divide until the decimal point. Do you understand? So I have to bring that 0 down, this other 0 down. And then I have to ask myself, how many times will 54 go into 0? Well, it's going to be 0. And then 0 times 54 is 0. I subtract that, and there's my answer. Okay? So when I divide this out, the plane has 150 seats. Okay? 81 seats that are empty is almost half the plane. 54% of the plane is empty. Okay? Are we good? Yes. So that's how we find the whole. Okay? That's the first type of problem we'll see. Here's how we find the part. Okay? You can use an equation to find a whole, a part, or a percent. So here we're finding a part. If you notice, what number is 39% of 377? So here, 377 is the whole. They're giving you the percent, 39%. They want to know, hey, I want to know 39% of 337, or 377. What's 39% of that, of the whole? What would be 39% or part of the whole? So using what we did earlier, see if you could set it up. And I want you to notice I'm going to color code things the same. So I'm going to go ahead and walk you through this first example. So we don't know what this number is, this part. We know the percent and we know the whole. So earlier we were trying to find the whole, and I color coded that blue in the last problem. So when you look at the notes, if you look at the notes again, you should be able to make that connection. So what I'm missing is the number, and I'm going to let n be that number. I could have let it be x, whatever, n. I just chose n. So my equation, does anybody want to take a guess what my equation is going to look like? Kata?
0.39 times extra n equals 377.
Okay, so if you look at your notes from the last problem, we were trying to find the whole part, right? So in your equation, the whole doesn't move. What I had for the whole part doesn't move. So look at my equation here. We had that before. What was in blue, we didn't have that. So your variable is going to be on the right-hand side of the equation over here. Okay, do you guys see that? All right, so now all you're doing is you're just multiplying to figure out what your variable is. Here's my equation. When I multiply it, that's my answer, but I want to walk you through that just for some review. So if I'm multiplying these two numbers, and I like that you got the decimal correct, okay, but just make sure your equation is set up properly.
That's
So
when you're doing the part.
when we're trying to find the part, yeah. So here we're going to multiply it. I want to review with you how do we find that. So 9 times 7, what is that? 63. Carry my 6. 9 times 7 again? 63. What's 63 plus 6? 69. Carry the 6. What's 9 times 3? 27. 27 plus the 6? 33. Okay. Now before I multiply the next digit over, I got to do what? Not a decimal. I got to put a 0. That's what you're thinking. So I put my 0, and now I'm going to go ahead and multiply this 3 in this place. 3 times 7? 21. Carry the 2. 3 times 7 again? 21 plus the 2 I carried? 20 what? 23. Carry the 2 again. 3 times 3? 9 plus the 2 I carried? 11. Now we're going to add all this up. And here's what we get back. 3 plus 0 is 3. 9 plus 1 is 10. I got to carry 1. So then I get 3 plus the 1, 7. 3 plus 1 is 4, and then 1. Now, remember, I have 2 placeholders here and 1 here. So 2 and then 0. Add those, I got 2 places. So I got to move this 1, 2 places. That's my answer. Do you guys see how we did that? Again, I'm reviewing multiplying decimals, but use that model to solve the next problem. The setup's the same. The setup's the same. So, who can share with me the equation they got? Samantha, what was your equation?
Okay, so I got 0 and 2700 times 60.
Nice. There's an equation, so there's an equal sign, there's a variable.
Equal n.
Nice. There we go. Okay, so the setup's correct. She has the right equation. If you didn't get this equation, I need you to go ahead and set up your equation and start solving it. So this is good practice because a number of you guys are losing points because you still don't know how to multiply or divide decimals. I'm trying to review this for you. You got it?
Yeah.
Okay. Caden, what is it?
I got 16.2.
Nice. 16.2 or 16.20. It's the same number. So if you got that, you're good. How many of you guys got that? Is there anybody who wants me to work that out for him? Okay, I'll work it out. No, it's okay. So we'll do this. It's good practice. I don't mind. Like I said this morning, I wasn't planning on reviewing this, but I feel like there's enough people that maybe I should. Okay, so 60 times 0, 2700. Let's go ahead and multiply this out. So 0, if I multiply this 0, it's just going to be 0 all day long, right? Okay, But you have to be careful. Just because this 0 in the 60 is there, and I multiplied it out, I still have to make sure I could put a placeholder before I multiply the 6. So 6 times 7, 42, carry the 4. 6 times 2 is 12, plus the 4, 16. Carry the 1. 6 times 0 is 0, plus the 1. Okay? And then I got to make sure my decimal's in the right place. So I'm going to add this all up. And here's what I get. 0, 2, 6, 1. And I got to move it in 2 places, right? Because I got 2 places here. I got no place here. So I got 2 places. So that means 1 and then 2. So it's 16.2. Maybe I should erase that and show you guys this way. 2 places. Okay? Are we good? Let's go to the next one. Now, if we found the whole in the first set of examples, we found the whole here in the first set of examples. What do we find? The part, right? No, we found the whole, and now we found the part. So what do we find next? We found, what do you think we're finding next? We're finding the percent. Now, if I got 8 answers correct out of 10, what percentage is that? You guys know right at the bat, what is it? 80%. How would I write that as a fraction? 8 over 10, right? And then I could divide. I put 8 in the house, 10 outside the house. It would give me 0.8, right? And then if I wanted to convert 0.8 or 0.8 into a percent, I would just move the decimal toward the percent sign 2 places. That would give me 80% back. Okay, so this problem isn't much different. I work out the long division for you guys on this problem, but how would I set up this problem? Let me read it to you. So this example, we're finding the percent. 3,072 teens were surveyed. 2,212 say they read for fun. What percent of teens surveyed said they read for fun? Well, think about the problem I just gave you. I need to set up a fraction. What's that fraction going to be?
2,212 over 3,072.
Nice. How do I write that as a decimal so I could turn it into a percent? I got to divide. So which number's in the house? The top is always in the if you're on top, you're in. If you're on the bottom, you are out. Okay? You don't want to be on the bottom because you get left out. Like the denominator is on the bottom. You're going to get left out. So watch what I do. I'm just going to go ahead and show you the work here. Okay? I worked out the long division. Some of you guys need to practice, but we don't have all day to go over every single thing required. So you're going to have to go back and get this if you don't know how to do it. I put this up here so you can check your work and try it on your own. Now, if you notice, this is about equal to this, but that's a decimal, and they want to know the percent. So can somebody tell me what the percent is? We have the decimal now. We did all the work. What's the percent going to be? Sergio? 72%. Very good. It's going to be 72%. 72% of teens surveyed said they like to read for fun. Do you like to read for fun?
No. It depends on what
No, you're not telling the truth. I don't know how many of you guys are reading Twitter or whatever. That's reading still, isn't it? Okay, that's what I thought. Thank you. Thank you. Okay, that's the model. I need you to set this one up. I'm going to read it to you, and I'm going to see if you guys can fill in a missing value. It says it rained 75 days last year. What percent of the year was rainy? What are they missing? How many days in a year? How many days in a year? 365. So, can you set up the fraction? Set up the fraction, write it down, set it up, and divide it. Get your decimal number so we can get to our percent. Come on, we got a quiz. This is our last quiz of the semester on Friday. So what's my fraction going to look like? Leonardo? Nice. Leonardo's correct. It's 75 days of rain per year divided by 365 days per year. So we're going to divide 75 by 365, and you guys know how to do that. Which number's in the house?
75.
Nice. 75 is in the house. So 365 is outside the house. Do we have to worry about moving a decimal or anything? No, but we do have to bring a decimal up. So let me walk you through. Hopefully you guys have gotten started. Have you guys started this out, working this out? Okay. Let me just speed things up because we are short on time. Take a look at this. Hopefully you got this started, and maybe you're halfway through this now, but here we go. Now, here's my answer. What is my percent going to be? 20%. I actually go a step further and I say, hey, it's 20 and 0.5%. It depends on what the question asks for, 0.1% or not. Now remember, yesterday there's 3 different scenarios. Finding a percent, finding a part, or finding a whole. That was what we did yesterday with proportions. We set up the proportion. It's 2 strategies to find the same information. Okay? Some of you guys were trying to solve it this way yesterday. So we're almost done. You guys still have 5 minutes left, so I don't know why we're packing up. Now, if you notice, these are the same. This is the same problem, but reworked the 3 different ways. Do you see the equations the same, but do you see how it's moved around, what the variable is? Okay, so for the percent, how would I solve this? I would divide everything by 25, right? That's why we were dividing up above. Okay, over here, this is like the second set of examples. And right here, this is like the first set of examples. Do you guys understand? The 3 different types I showed you already. Now, we're going to finish this up. We're almost done. Do the following questions mean the same thing? Yes or no, explain. 20% of 40. 20 is what percent of 40?
Yeah.
20 is 40% of what number? Do those 3 things mean the same thing?
Yeah.
So tell me this. Tell me in the first one, am I trying to find the part, the whole, or the percent? Well, they already give me percent. Look, it's 20% of 40. The part, because they're saying 20% of 40. They want to know the part of 40, that's 20%. So this asks for the part. What is this next one asking? 20 is what percent of 40? What's it asking for? It's asking for the percent. So it gives me the part and the whole. Okay? And what about this last one? The whole. 20 is 40% of what number? Of what whole is 40% of? Okay? So we're going to say no because these ask for different things. Do you understand? Now, take a look at these. We're going to match each of these questions with the equation on the right column. So these in the first column over here, we're going to match with one of these equations on the right-hand side. So the first question says, what is 16% of 200? So which one does that match up with? So I have the percent, right? I have, what are we trying to find? The part or the whole or the percent? What are we trying to find? We're trying to find the part. So how do we go about doing that? That was like the second set of examples I gave you. You guys remember? So what equation does that look like? Remember those examples? If you look at your notes and look at those second set of equations that we worked on, then you'll have it. Kimberly. No, it's not the first one. Akmana? Not the third one. So it's got to be, it's going to be the middle one.
Right there.
Okay. 16 is what percent of 200? How do we figure out the percent? I'm going to divide. So which one of these problems would I be dividing? There's 2 of them. So which one would it be? The last one. Nice. Okay, and then obviously 16% of what number? If we're trying to find what? The part, the whole, the percent. the part, because they're saying we're trying to find 16% of 200. That's the part. Okay, the last one, I don't need you to solve this, but I do need you to set up the equation for both of these. That's it. We're done after this. Set up the equation for both of these. Set up the equation. Let's wrap this lesson up. What percent of 625 is 500? What's that equation look like? Who can take a guess at it? Richard, what do you think that is? We're trying to find the percent, right? Let me walk you through it. Look. If I multiply, have a seat. If I multiply the whole by the decimal from the percent, I get the part, right? So to solve this, here's what we got. Okay, what number is 5% of 520? How do we figure out the part? Look up here. How do we figure out the part? We have some examples up above. What am I doing? But tell me the equation. What am I going to do to find the part?
So first you have to turn the percent into a decimal.
Right, and then what?
Then you have to divide it by the whole number.
No, we're going to multiply it by the... So we turn it into a decimal and multiply it by the whole. And here's what that simplifies to. Okay, make sure you do the homework. Line up. Quickly line up. Have a nice day.